The project-based learning bilingual STEM physics module was developed for students at the secondary education level to learn classical mechanics. The process of developing the project-based learning bilingual STEM physics module was done by referring to the ADDIE model framework, which consists of analysis, design, development, implementation and evaluation phases. The main components, namely STEM PBL activities, physics module and video production. These components are interrelated and contribute to how students learn classical mechanics at school. The STEM PBL activities component provides the mechanism for students to learn classical mechanics. Meanwhile, the physics module component serves as a reference for students to follow the steps in implementing STEM PBL activities and becomes a place for students to write down their progress and reflection, record data and findings, as well as solve physics problems. The video production component serves as an extra learning activity in which students produce a short video for each STEM PBL activity to summarize their learning experience by combining and editing the visual media resources taken during the STEM PBL activities intervention. These three STEM PBL activities have similar frameworks in which students engage in scientific inquiry, technological literacy, engineering design process and mathematical thinking to construct a product for 4 weeks of intervention. The water rocket project is building 2 water rockets that are respectively capable of landing on a designated target and can safely carry an egg where the egg remains intact after landing. Meanwhile, the egg drop project is building a device purposely to protect an egg from breaking when it falls from a certain height. Then, the spaghetti bridge project is building a stronger spaghetti bridge that capable of holding more load. Based on the PBL model, students have to follow 9 steps to achieve the learning objectives for each STEM PBL activity in 4 weeks of duration. Each step has its own learning activity and students have to accomplish 1 step before moving to the subsequent step. After being done with the first STEM PBL activity, students repeated the 9 steps of the PBL model once again to implement the second and third STEM PBL activities. The first step is called Build the Culture as the startup to implement the STEM PBL activities in the first week. In this step, at first, the facilitator introduces to the students about the use of the project-based learning bilingual STEM physics module as an alternative instruction to learn physics by doing a project in a small group by following the guidelines provided in the module. Then, the facilitator elaborates further that at the end of each STEM PBL activity, each group is able to come out with a final product, produce a short video and complete the module. After accomplishing the first step, then continue with the second step called group setting. In this step, students form a group consisting of 3 or 4 members and each group is assigned a group leader after the briefing session by the facilitator. Subsequently, the facilitator distributes the module to each group. Each group has to set up ground rules in order to function as a group during the intervention. After achieving the second step, then continue with the third step, called Essential Question. In this step, each group brainstorms about the essential question and comes out with 2 draft ideas on how to solve the essential question and presents their ideas through sketches. From the 2 sketches, each group discusses and chooses which design is the best to be developed as a final product by considering the manipulative variable, responding variable and constant variable. After completing the third step, then continue with the fourth step, called Sustained Inquiry, in the second week. In this step, each group engages in extended process of finding resources on what physics concepts and additional information in which they can relate to and apply in order to construct an ultimate end product. Then, each group constructs a prototype to test the effectiveness of their design in the first week and make improvement after experimenting. After accomplishing the fourth step, then continue with the fifth step, called Decision Making. In this step, each group makes a final decision in choosing the ultimate design to be developed as the final product based on their research findings and group discussion. After achieving the fifth step, then continue with the sixth step, called Execute the Solution. In this step, each group starts constructing the final product after deciding on the ultimate design. After getting done with the sixth step, then continue with the seventh step, called Public Product, in the third week. In this step, all groups are gathered to exhibit their final product for product testing. Before and during the product testing, each group does specific measurements that are required in the module. During the product testing, each group tests the final product by presenting it to the audience. After achieving the seventh step, then continue with the eighth step, called Assess Student Learning. In this step, each group solves the physics problems in the module. Students use their experiences from the STEM PBL activities to solve the physics problems in the module by making connections and applying the classical mechanics conceptual understanding they have acquired in STEM PBL activities. Each group continues to solve the physics problems in the 4th week. After completing the 8th step, then continue with the 9th step, called Evaluate the Experience. In this step, all groups once again gather to share their opinions, beliefs, attitudes and experiences about the intervention with the other students, as well as do a short video presentation at the end of the 4th week. After completing all 9 steps, students follow the same steps to implement the 2nd and 3rd STEM PBL activities in the module. In each week throughout the intervention period, meeting sessions are held for each group with the facilitator. The facilitator helps to facilitate the students with their doubts, achieve conceptual understanding, and encourage students to communicate their progress not only to their peers but also to the facilitator. Besides that, each student reflects on his or her experience with the intervention weekly by writing their reflection in the space provided in the module. The project-based learning bilingual STEM physics module provides opportunities for students to design, sketch, construct and test prototype. Besides that, students use their experience from the STEM PBL activities to solve the physics problems in the module by making connections and applying the physics concepts understanding they have encountered while constructing the final product.
Integrating STEM elements into the module can effectively equip students with the necessary competencies to tackle the 4th industrial revolution and empower them with the 21st century essential skills to thrive in this new era.